Last time we started section 2.1 and we're looking at reasoning and logic. We had just been working with truth tables when we left off, and we had encountered two different types of truth tables. Well, kind of three. We looked at one for negation. It's not a very exciting one, but we did look at it. And then we looked at conjunctions, which are and statements. They're true when both statements are true. And disjunctions, which are or statements, and they're true when either statement is true, or both. It could be both. And we had done an example and considered what happens when we combine things in different ways, including a negation in there. And we are to the point where we're going to take a look at what logically equivalent means. So, two statements are logically equivalent when they have the same truth value in every possible situation. And we write logically equivalent statements with, it looks kind of like a triple equal sign, or it's 3 lines anyway, like this. So if two statements are logically equivalent and the statements are P and Q, it's P and you've got this triple like line equals Q. And what that leads us to is De Morgan's laws. So De Morgan's laws, which there's no triple equals on my computer, that's why they're missing them, so we'll just put them in right here for ourselves. De Morgan's laws talk about specific statements, namely conjunctions and disjunctions, and what happens when you negate them, and how to create their logical equivalent counterpart. So if you negate an and statement, it will become an or statement. But it'll become an or statement with each of the individual statements themselves also negated. And it almost feels like what you do when you do algebra and you sort of distribute a negative through something, right? So the negation comes through to the P and it makes it the negation of P. The negation actually affects the and statement and makes it an or. There it is. And then the negation comes through to the Q and makes it the negation of Q. We'll see some actual language components of how this works, but the same is true for an or statement. So when we have a disjunction and we negate it, it does the same thing. It negates the first statement, it negates the or so that it becomes an and it negates the second statement. Okay, so it just pieces its way through. So the first example we're going to do is actually how it works with language. And if you really stop and think about the English that you use, you do this. You might not just think about it this way, but you do. So here's our example. Oh, wait. Do I have it there? This is the one I want to jump to. So I want to do this one first, and then we'll go back and we'll do the other two pieces. De Morgan's laws to write a negation of this. It's example 5. So we'll go back to examples 3 and 4, but I want to look at example 5. So there's two statements. It is not sunny, and I will go for a walk. And they're joined with the connective and. So this is a conjunction. So we're going to take the first piece and we're going to negate it. So what is the negation of it is not sunny? It is sunny. So don't overthink this. It is sunny. We're going to negate the and it will become or. And what's the negation of I will go for a walk? Yeah, I will not go for a walk. So if somebody came to you and they made the statement that's written here originally, it says, it is not sunny and I will go for a walk. You have a picture in your mind of what that looks like, right? Okay, picture what's happening. It's cloudy, it's rainy, whatever outside. Something outside, it's not, the sun's not shining and somebody's going for a walk, right? That's what you're picturing. If you have the negation of that, then it will be what we just wrote down. Either it is sunny and they're still going for a walk, that's an option. Or maybe it is sunny and they're not going for a walk. Either of those things are happening. Or they're not going for a walk and it's not. Like there's pieces of that. We have to take a look at all the different ways that could be false. So we put the or in between, and it means the first statement might be true, so it might be actually sunny. Or the second statement might now be false, right? So it's changed and it's now they're not going for a walk. So we do this with our English all the time when we negate a statement that has an and or an or with it. We're just doing it from a concrete standpoint of logic by writing it down this way. So let's go back and do the symbols part of it now that I skipped. So we're going to use De Morgan's laws to simply rewrite, this is symbol rewriting, the statement P and tilde Q. So I'm going to write down what this is actually asking. This is asking for the negation of P and tilde Q. And it will be logically equal to what? So we're going to do piece by piece. P will become tilde P, thank you. And will become or, and tilde Q will become Q. Okay, does that make sense? So what we're going to do for number 4 is we're going to show that these two statements are actually logically equivalent using truth tables. Now, there's no context to this like there is over here. That's why I wanted to start with the context one and flip my examples around. But we're going to show that this idea of distributing this negative through, right, this negation through like we just did, really works from a logic standpoint. We're going to do that with truth tables. So you're going to create a truth table. We have 2 statements in our truth table, just like we've been working with. You've got P and you've got Q. And we're going to work with the left-hand side first. So we have, I'll label P, Q. Notice that if I'm working from the inside out on the parentheses, I also have a tilde Q on the inside of the parentheses. So I need tilde Q. And then it says I'm going to join those, that is P and tilde Q, with an and statement. That's everything inside the parentheses. And then I'm going to negate it. Okay, working from the inside out on the parentheses on the left-hand side. And in fact, I think, let me just highlight this in a different color so that we can call it with colors as well. So we're working on the red side right now. Okay, everybody good so far? Ignore the blue side. It's going to come into play in a little bit. We're just working on the red side. All right. Do you remember what's in the P column? Right. True, true, false, false. How about the, that's a weird F. Let's try that again. What's in the Q column? True, false, true, false. They're always like that, right? Now we're ready for the negation of Q column. So what will I get in the tilde Q column? False, true. Almost for free, you get that, right? Always works that way. The next column is the first column that we have to work a little bit for. It's an and statement. When is an and statement true? When they're both true. And I want to remind you which 2 statements we're looking at. It says we're looking at P and we're looking at tilde Q. Here we go. So we want to make sure we're looking at the right columns before we make our decisions. We need them to both be true. So along row 1, I have true, false. That would be false. And then I have true, true. That one's true. Third one is false, false. And the 4th row is false, true. Okay, so this is T's and F's and all the things. And then the last column is going to take the column I just created and do what? Flip them. So the first one was false, now it's true. The second one was true, now it's false. False becomes true, and false becomes true, and we're done. Okay, so this is one truth table. You could continue within the same truth table, but I want to make it really clear that what we're really doing is we're separating these 2 arguments by looking at their individual truth tables. So I'm going to go with it being a separate truth table. It will still have a column for P and Q like we had before. Wow. However, I don't have tilde Q on this one. What do I have? I have tilde P, so I need a tilde P column. And then I need a column that combines everything. So this is a simpler one, tilde P, and it's an or statement that it's combining it. P and Q columns are going to look just like they did before. That's why I said if you wanted to put it on the same truth table, you could. What is my tilde P column going to look like? False, false, true, and true. It's the reverse of column P, the first column. Now I'm going to consider Q and tilde P, and it's an or statement. When is an or statement true? When at least one of them is true, right? So looking at my blue columns, the first one's true, the second one's false. So true, false is true. Row 2, false, false. Yep, false. Row 3, true, true. Row 4, false, true. True. And here's what I want to point out. The ending results on both of our truth tables match. That makes the two statements logically equivalent because they have the same resulting truth column. And that was our definition on the previous page. So De Morgan's laws and this structure work to actually negate a statement. Okay. We have one more type of connective. So we talked about 3 types of connectives. We mentioned 3 types of connectives last time. We mentioned the conjunctions, that's the and statements. We mentioned disjunctions and the or statements, and we talked a lot about those. We only barely mentioned the third one. It's an if-then statement, okay? And an if-then statement is called a conditional. So conditional statements are those that are expressed in the form if P, then Q. Sometimes we also read them as P implies Q. And they're written with an arrow. So P, and then it's got an arrow, and then Q. So the reason we kind of like the phrase if P, P implies Q is because you can sort of read it from left to right with the word implies being read in the place of the arrow. So that's kind of why that one's nice. All right, so the hypothesis is the if part of the conditional. If this is holding, right, you're assuming this if part is true. Conclusion is the then part of the conditional. Okay. And we're going to create a truth table for this one, and this one is the most kind of confusing compared to the other two. I think this one is more confusing. And I need to change my example. I can't use the math teacher, what was it, math teachers and moms. That's what I think I did last time, right? I can't use that one for this to work. Okay, so are you ready? Okay, we're going to create 2 statements. And we're going to create a truth table. Our truth table is going to have a P and a Q. So I'm going to go ahead and draw the basic setup. It's going to look much like the other ones. I'm having random marks. I'm going to show you. Okay, so I have a P and Q, and then I'm going to have a P arrow Q. And I need my P and my Q to be defined for my statements. Okay, so P is the statement, I am a mom. And Q is going to be the statement, I am a woman. You could use dad and man here too, it doesn't matter. We're just going to pick one. That's how I used mom and women. Okay, so I need people standing in the hallway, so I got to think of them now. Who's going to stand in my hallway? So the first one can be me. So I come in the hall, or come in from the hallway, and I say, I am a mom, therefore I am a woman. And you would look and you would say, that makes sense. That's a true statement, right? I'm a mom, therefore I'm a woman. Or if I'm a mom, then I'm a woman. That's how I should have said it, sorry. If I'm a mom, then I'm a woman. And you say, yes, that makes sense. Okay. So the next one, they come in and they say, it's a true, false statement. They say, the first part, I'm a mom, is not a true statement. But then they still say, did I write these in the right order? Just a second. Okay, the next person comes in and then they say, I am not a mom. No, I am a mom. Sorry, that's still true. The first part's true. That's what I was missing when I was reading it. I am a mom, right? But I'm not a woman. And you would be like, You so sure about that? That doesn't quite work, right? You're taking the first part to be a true statement. They're a mom, but they got to be a woman, right? Biology, that's the way it works. So this would be a false statement. Those two are pretty straightforward. It's the last two that are a little confusing. Both of them start out false, and then they've got one of them's true, one of them's false. So in both of these scenarios at the end, you have people who are not moms. So one of them comes in and says, I am not a mom, therefore I'm a woman. And the other one comes in and says, I am not a mom, therefore I'm a man. And either of those two statements could work, right? Right? Them not being a mom, in fact, I have both options in here. Do any of you guys have any kids? Nobody does. All right, so Lily comes in and she says, I'm not a mom, therefore I'm a woman. And we're like, yeah, okay, this works. And Ethan comes in and says, I'm not a mom, therefore I'm a man. And you're like, okay, that works. It's just fine, right? Both of those can be true. So both of these statements are true statements. Not because they couldn't be false, but because the default is to believe the person that said the statement. Are you with me? Okay. So look at when a conditional is true. There's two types of statements or two types of forms for which a conditional is true. One of them matches the same that was the conjunction and the disjunction. The true statement, it's always true. It doesn't matter if it's a conjunction, a disjunction, or a conditional. True is always true. But the last two are different, right? The last two say that if the hypothesis starts out false, then it's automatically assumed to be a true statement. So a false hypothesis can result in any kind of a conclusion, and it can hold. It can work. So those two ways, right? True, that one always is working. And then false anything is a true statement. So we're going to do a couple more examples and be finishing up. All right, so P is the statement, you build it. Q is the statement, they will come. Do you know what it's from? This is an old movie. It's called Field of Dreams. Kevin Costner's in it, if that name is familiar to you. Field of Dreams, very old statement, and a gentleman is building a baseball field in the middle of a farmland. Doesn't make any kind of sense. It's kind of one of those like, he's going out on faith and believing that he's supposed to be doing this. It's a very interesting movie. It's kind of fun. So that's what this is from. All right, so we're going to first take these components and we're going to write them in symbols. So the first one says, they will come if you build it. So I bring this to your attention because the if seems to be in a funny place, does it not? We use this in our English all the time. We move the if. You just need to start where the if is. This part is the hypothesis, because it comes after the if. Okay? So even though it's at the end, it's after the word if, it's my hypothesis. So if you build it, they will come. If you want to think about it this way, is that you could move this to the beginning and rewrite the statement and it would mean the same thing. So if you build it, what symbol is that in our descriptions above? That's P. And then I've got an arrow. They will come is the conclusion, so it's the Q. So this is just P arrow Q, but written in a slightly different way. The next one has the if at the beginning, so we don't have to move anything around. We just start here with if. It says, if you do not build it, how will I represent that in symbols? Tilde P. Then I have the word then, that's my arrow. It says, they will not come. What would that be? Tilde Q. So tilde P implies tilde Q. And now we're going to go the other direction. We're going to be given symbols and write the corresponding statements, but our statements have changed. So P is the statement, God loves me, and Q is the statement, I'm a sinner. Okay? Now I'm incorporating not just the new symbol, the arrow, but one of the ones we've seen before. So what does that upside down V mean? And. Good. So we're going to write the P statement down first, which is what? God loves me. And then you already told me it was an and, so I'll put an and next, and what comes after that? I am a sinner. And that is definitely one of the components of what we believe and our faith, right? God loves me and I am a sinner. They're not exclusive categories. The next one is going to feel funny when I write it down, but I kind of throw it in here because I want you to understand that sometimes the things we write down they're not actually truth, okay? That's what I want you to recognize. So let's look at this one. Tilde P would be what? God does not love me, which is already a false statement, right? Already false. Okay, but I needed something before. What should have come before God? Yeah, an if. So the arrow means that I needed an if statement. If should have come at the beginning. What would come after this then? Yep, the then. Then what? Then I am a sinner. So this would be one of those bottom two lines of my truth table where the hypothesis at the beginning was already false to start with. And so it ends up being one of these statements that doesn't quite sound right. And if you read that, you're probably thinking, that doesn't sound quite right. And it doesn't, right? Because the statement at the beginning being false is actually a false statement to start with. Okay, the last thing in this section we're going to look at are statements and converses, inverses, and contrapositives. Okay, so a statement, this is just a notation for it that we've already talked about, is P arrow Q. That's our notation for a statement. If you build it, they will come. Okay? What the converse does is the converse switches the order around. So the Q and the P switch places. So this is Q implies P. These are not necessarily statements that are logically equivalent. That's my note at the bottom. Some of these statements are equivalent to one another, but they're not all equivalent to each other. Okay, so these are not similar. These are not equivalent statements all to one another. So if you build it, he will come is not actually the same statement as if he comes, then you built it. I have to change the verbs around for it to work in sentence structure, but that's not the same statement. Inverse keeps the order the same. So you have a P and you have a Q, but it negates them. So it's the tilde P implies tilde Q. So this one would say, if you do not build it, then he will knock, then they will not come, or whatever, he will not come. I can't remember how it was worded, but something like that. So you put the word nots into places. And the contrapositive does both. It flips the order and it negates it both. Okay? So we flip the order. We have Q first, we have P second. We have negations on both of them, and we have the arrow between, like that. So you negate and you flip. I already told you the first two are not equivalent to one another. However, there are some equivalencies between the inverse and the contrapositive and the original statement and its converse. So those will come into play. But I want you to see an example of this that you may have seen before. So I'm going to pause the video and we're going to play, if I can get it to work, we're going to play a clip. Are you ready? Okay. So what we're going to take a look at then is we're going to take a look at creating these converse, inverses, and contrapositives, and we're going to use the monkey tail one because we just saw the video and it was funny, okay? All right, so we're going to create the converse, inverse, and contrapositive. This is the statement. If I am a monkey, I have a tail. And I know we don't see the word then in there, but it is an understood then. If it helps you to feel like it's more complete to put it in there, do it. But it's fine if it doesn't have it as well. And we're going to do converse, inverse, and contrapositive. Okay, converse does what? It flips it. Okay, so it doesn't negate anything. It just flips the if and the then parts around. But the word if stays at the beginning. Don't move the if. Okay, if stays still, and it will stay still in all the cases. Okay, so instead of it saying if I'm a monkey, it will say if I have a tail. And this one works really nicely. I don't have to change any verb usage, but sometimes you do with the if-then statement. So feel free to adjust verbs to make them make sense from a grammatical standpoint. So this one is if I have a tail. What would come next? Yeah, then I am a monkey. What would I do for the inverse?
I'm
if I am not a monkey, so the order stays the same from the original statement, but we negate it, and we would say, then I do not have a tail. And the last one, the contrapositive, what would it be? So we said, if I do not have a tail, so we negated the second part, then I am not a monkey, and that's a negation of the first part. Does that make sense? All right.